The objective for this section is students will be able to define a mineral and also explain how to identify minerals. Rocks are made out of minerals, but minerals are not made out of rocks. To determine whether or not a substance is a mineral, 4 requirements must be met. Number 1, the substance must be inorganic. What does inorganic mean? It means not made from living things or ever made from anything that was once living. Number 2, the substance must occur naturally within the earth. It cannot be man-made. Substances that occur naturally are usually mined, like silver, quartz, and sulfur. Man-made substances, like plastic or steel, are not found in the earth and therefore cannot be minerals. Number 3, the substance must be a solid. It cannot be a liquid and it cannot be a gas. Petroleum occurs naturally in the earth but is not a solid, so it cannot be considered a mineral. And number 4, the substance must have a crystalline structure. A solid whose atoms, ions, or molecules are arranged in a definite pattern. So, a great definition for a mineral is a naturally formed, inorganic solid that has a definite crystalline structure. And now the question is, what makes up minerals? First, an element, a pure substance that cannot be broken down into simpler substances by ordinary chemical means. A compound, a substance made up of 2 or more elements that are bonded together. A mixture, a material that contains 2 or more substances that are not chemically combined. All minerals can be classified into 2 different groups. The first is silicates, minerals that contain a combination of silicon and oxygen. These minerals make up more than 90% of the Earth's crust. And number 2 are non-silicates, minerals that do not contain a combination of both silicon and oxygen. And these include carbonates, halides, oxides, sulfates, and sulfides. There are people who actually study minerals, and they can actually identify different minerals based on the properties that these minerals display. We're going to take a look at these different properties. Okay, the first property is color, and this can be a little bit misleading, so we're going to take a look at a different type of test later on called a streak test. Also, there's luster, the way the surface reflects light. There's a few different ways of describing luster, the first being metallic, the second is non-metallic, and the third being vitreous. As you can see, metallic, it's really shiny. Non-metallic is more dull, and vitreous, it's when light can pass through the mineral. So when scientists take a look at a mineral, they actually take a look at the streak, the cleavage, the fracture, and also the hardness in an attempt to identify the mineral. The streak is the color of a mineral in the powdered form. As we talked about this earlier, when you're just taking a look at the rock itself, it may be red, it may be blue, it may be brown, but once you actually start to grind it against a porcelain plate, it will leave a fine powder. And the way that the light is reflected off of that color may be different than it is in its natural form. So this is called the streak plate test. In addition to the streak plate test, we also take a look at how the mineral breaks. If it breaks along a very clean and smooth plane, it is said to have cleavage. As you can see in this picture, this mineral actually breaks very cleanly, and it has a symmetrical break on either side, and this is known as cleavage. Some minerals break unevenly and along curved or irregular surfaces. This type of break is called fracture, and this sets some minerals apart from those who have cleavage. In addition, we also have the Mohs hardness scale. A hardness of a mineral is its resistance to being scratched. If a mineral on the Mohs scale scratches another mineral, then the mineral is not as hard as the mineral that scratched it. Very simply put, if you take a look at the chart above, talc, which is the softest, has a hardness of 1. And then if you work your way all the way over to the right, which is a hardness of 10, it's represented by a diamond, which is the hardest of all minerals. And we also have another property that can be used to identify a mineral, is its density, which of course density is equal to its mass divided by volume. And you might be asking yourself, well, how can we figure out a mineral's density? You can actually take a graduated cylinder and fill it with water and drop the mineral into the graduated cylinder, and that would give you the amount of displacement. If we measure the mass of the mineral and divide it by the displacement in milliliters, you can actually find its density. Some other notable properties that you can use to identify minerals: a chemical reaction, perhaps vinegar; optical properties, whether or not a black light makes the mineral glow in the dark; magnetism; radioactivity; and finally taste. But we never use taste in the lab because you never know what you're actually tasting, so we never stick any minerals into our mouth. And that concludes our long distance learning narrative PowerPoint video.